Hi, welcome to this video. In this video, we will discuss about how to find out the number of solutions, the integer solutions of a linear equation. And this we are going to understand by help of one of the examples, and the example that I intend to take here is this example. So in this question, when we have the positive integer n is divided by 3, the remainder is 2, and is divided by 7, the remainder is 5, we will solve this question in various ways. One, the simple substitution of numbers and finding out the common solutions, and towards the later part of the video, I would like to just reflect how to find out the integer solutions and how the solutions are related with the coefficients of the unknown variables. So I'll start this with the discussion of the question first, and then we'll discuss the concept towards the end. When positive integer n is divided by 3, the remainder is 2, and when n is divided by 7, the remainder is 5. So here I am going to write the number n as a multiple of 3 plus 2, and also when divided by 7, the remainder is 5. Usually, how I answer these questions is, if I can answer them without using much of maths, I always prefer that, so I can quickly start making the list of the numbers which satisfy to these conditions. In the first column, I can start from number 2. That's really important because the value of a can be 0, and when 2 is divided by 3, the remainder is still 2. And likewise, I can write more numbers. So after 2, the next number will be 5, then the next number will be 8, and then the next number will be 11, 14, 17, 20, 23, 26, 29, 32, 35, 38, 41, 44, etc. and 47. Now, in the second column, I think here there will be too many numbers because we have to write up to 100 and there are 33 multiples of 3, so there can be too many numbers. So that's not really a wise thing to write all the numbers in the first column. Instead, the better idea is to write all the numbers in the second column if that makes it any convenient. And it is convenient because there will be only 14 multiples at most of 7 from 1 to 100. So the first number starts with 5, and then next number is 5 plus 7. That is 12. The next number is 12 plus 7, 19. Next number is 19 plus 7, 26. So that's how the next numbers I'm calculating. I'm not substituting the values of b. So 26 plus 7 is 33, then 40, then 47, 54, 61, 68, 75, 70, 82, 89, 96. Now the next step is to find the common numbers that we have available in both. So the first common number is 5. Now the next common number that we can see is 26. Right? If you want, you can see the next common number as well, and I can see the next common number is 47. Now by doing so you can find out the answer, but here since I would like to teach you a couple of things, so my objective is to take you into the basic. First thing, understand why do we have first number 5 and then second number 26 and then the next number 47. There are various patterns that you can identify. For example, in the right column you can see that the next example is being obtained after leaving two examples in between. So after 5 we left two values, then next, then we left two values, then next, then we left two values, so the next value certainly has to be 68, then the next value has to be 89. So that way we can find out all the solutions. There are 5 solutions, so the answer is E option. That's one way. But let's understand mathematically why is it happening, what is happening. After 5, the next number is 26. 26 is 21 more than the previous number. After 26, the next number is 47. 47 also is 21 more than 47. If you understand this pattern, you can identify the next number by adding 21 here. That becomes 68. And once again, if you add 21, the next number will be 89. So once again, we have 5 numbers, right? Now the question is, why are the examples differing by the number 21? So the part is that the first series represents any two numbers which are at a multiple of, which are at a gap of a multiple of 3. You take any two numbers, the difference between any two numbers in the first column will be a multiple of 3. Similarly, difference of any two number in the column 2 will be a multiple of 7. That means the solutions should be available at a gap which is a multiple of 3 as well as 7. So a multiple of 3 as well as 7 is the LCM of 3 and 7, and LCM of 3 and 7 is 21, and that's where this 21 is coming, LCM of 3 and 7. So LCM of divisors is what the number differs. Alternatively, so that's another way. Alternatively, we could also look at this equation that whenever you have any such linear equation such as 3a plus 2 is equal to 7b plus 5, you can always see that their solutions will always differ by the coefficients of each other. That means the value of a will differ by the coefficient of b, and the value of b will differ by the coefficient of a. So that's how we find the solution. For example, for the first solution, a was 1. The next solution was a equal to, at a difference of 7, 8. 8 into 3, at a equal to 8, the number becomes 26. That's the second solution. At a equal to 1, the number becomes 5. And similarly, the first value of b, for which the value of n was obtained, was 0. So the value of n was 5. The next value of b should differ by 3. So we are increasing it by 3. So n becomes 3 into 7, 21 plus 5, that is 26. That means the next value of a will be 15, the next value of b will be 6, the next value of a will be 15 plus 7, which is 22, and the next value will be 22 plus 7, that is 29. So if you start substituting these values, you once again get your answer. So this is the rule of linear equations, which is what I wanted to tell you, and the values of n you can keep finding out using this principle. And it's a really very effective principle to find out the solutions, the integer solutions of any linear solution and any collection of linear equations. So here also you can get the same values, b equal to 6, b equal to 9, b equal to 12. So 12 into 7, 84 plus 5. So last solution is 89, and the second last solution is 68. This is one really important rule. I hope this helps you understand this concept and ingrain how to find out the evolutionary emerging patterns in the numbers. Thank you so much for watching this video.